Okay, so now we are taking a look at question 2, and we're going to keep using the same function as before, but now we're going to think about the context of this function. And so this function, v of x, is actually going to give us the volume of an open top box. So we're going to picture that we're removing these x values some distance from each corner so that we can fold the remaining part up into an open top box. So we're going to remove some length of a square, right? That's x by x, and then fold it up to make this open top box. So if I were to try to write this as a function, notice I'm talking about taking all 10 centimeters of my rectangle, and I'm removing x twice because I'm removing it once over here and once over here. So that's how I get a length of 10 minus 2x. Same idea here, 6 centimeters, I'm removing x twice. So I have a width of 6 minus 2x. And then when I fold it up, I see that the height of this box is going to be whatever x is. So it's going to be a height of x. So that's where I get this function, length times width times height, right? To create my box. So my x value represents the length that I'm removing here. And my y value is going to represent the volume of this box. So the first thing I have is I have the same function we already graphed. This is a screen grab of what you might see on your calculator. So I'm going to go ahead and label everything we had found before, just so we know. So this 0.00, this says that if we remove 0 inches from our corner, then our box has a volume of 0. And that makes sense because we really can't have a box if we don't remove any part of the corner to fold up. My next x-intercept says that if I remove 3 centimeters from the box, then I have a volume of 0. And again, that makes sense because if I remove 3 centimeters, I get 6 minus 6, I get no width here, right? I don't have enough length. I've removed 3 centimeters from one side and 3 from the other. I have nothing left. Okay, and then same thing over here. We have, if I remove 5 centimeters, I have a volume of 0. And again, that makes sense from right here, because if I remove 5 centimeters, I'm going to get a length of 0 here. So then I also want to put in my local max, which says that if I remove 1.21 centimeters, then the volume of my box is going to be 32.84 centimeters squared. And my local minimum says if I remove 4.12 centimeters, I'm going to have a volume of negative 16.24. That ordered pair doesn't really make much sense because I can't really have that negative volume. So that ordered pair maybe doesn't make the most sense. So what we're going to think about right now is feasible domain. Feasible domain is going to be a portion of your regular domain. So it's the portion of the function's domain. And it's specifically the function the portion of the function's domain that makes sense when you think about the context. So it's the portion of the function's domain that makes sense specifically in the context of the situation. So now, even though situation, I can't spell, sorry, situation. So even though before our full domain was negative infinity to infinity, our full range was negative infinity to infinity, not all of those ordered pairs are actually going to make sense when we think about them in the context of this situation. So if I think about what actually makes sense in the context of this situation, I'm going to take a look here and I'm going to say it's never going to make sense. right? It's never going to make sense for x to be negative. We can't ever remove a negative portion from that corner. We can't remove a negative length. That would be like adding length to it. So that wouldn't make any sense. Now, it also makes sense to tell ourselves that anything where we get a negative volume, that definitely doesn't make sense either, right? Now, here's where it gets a little bit tricky. I have to determine, does it make sense for us to remove anywhere more than 0 and less than 3 and to have this positive volume? That does make sense to me. But what if we remove more than 5 centimeters? Is this section going to make sense in the context? Well, let's double check. If I remove more than 5 centimeters, if I remove 5 centimeters, we already said that we get 0, right? If I remove more than 5 centimeters, let's say I remove 6 centimeters, now all of a sudden I'm getting a length of my box that is negative. So that doesn't make sense in the context of my problem. So this whole section right here, once I remove more than 5 centimeters, my length is negative of my box, and that doesn't make any sense. So that part of my function doesn't really make any sense either. So the only portion of my graph that makes sense in this in this context is to remove between 0 centimeters from the corner and 3 centimeters from the corner, so that I always have positive length, width, and height, right? And then I also have a positive volume, right? I have to have a positive length, width, and height and a positive volume for this to make sense. So the space where that happens is between 0 and 3. And it doesn't make sense for us to remove 0 centimeters or 3 centimeters, because it gives us a either something that can't be folded. Like if I remove 0 centimeters, I can't fold this into a box. If I remove 3 centimeters, then I'm going to get a width of 0. That doesn't make sense. And a volume of 0 doesn't make sense for a box either. So my feasible domain is only from 0 to 3. And this is because we can't have a negative dimension of our box, right? It doesn't make sense for length, width, or height to be negative, or a negative volume. That doesn't make sense either, for us to have a negative volume. So we had to just reason through which part of this function makes sense.